This tutorial is for the drawing sheet for the Cowcatcher. So you want to click on New, and then RH Drawing Sheet Template, Create. Once we get here, we want to fill in the table, making sure we're using all caps. Train Cowcatcher. Student name, and the period. Now this drawing sheet is going to be fairly complex. We're going to bring the base in, select the file, Train Cowcatcher. Choosing a front view can be kind of difficult on this one because it's a complex part, and complex parts tend to have you could consider more than one front view, or different people might consider certain things different fronts. For our purposes, I'm going to use this as the front view. It looks a little small, but I think, considering we may have extra views, that I'm going to leave it this size. I can go back and change the size later. We'll go back and get a top view, an isometric view, and a side view. Now I know off the bat I'm going to need a back view and probably a bottom view as well. So I'm going to keep that in mind. As a matter of fact, I'm going to go ahead and get a bottom view. I'm going to slide this up slightly. Project. Cancel, sorry. You need to make sure you've highlighted this one so the box is around that. Then project geometry. That would be sort of the internal view. Now we can see inside. And if I want to do a back view, which I probably will, I will leave a little room and just have it here in the center. So I'm just sliding these up a little bit to give myself some room. I'm going to go ahead and shade the top one. Now I don't remember putting a color on this, so that's fine. We can add color when we do the assembly. Right click around the red dotted box. There we go. Okay, so as far as dimensions are concerned, we need to make sure we give all of the dimensions that we used to create the part in Inventor, and or that might need to be used in the shop to create this. So we're definitely going to need the views of the window that we have here, the cutouts. We definitely need a view that shows the large triangle shape and the small triangle shape, which we have both of those. We need a view that shows the extrusion thickness of the shell, the cut thickness of the shell, as well as the thickness of the extrusion for the pegs. If we zoom in here, we can also see the chamfer on those pegs, so we need that. What I'm probably going to do is do a detail view, which allows you to zoom in. We haven't done a detailed view yet, so we'll do a detailed view when we get to dimensioning the peg. So let's go ahead and start putting some dimensions here. We needed the top outline here. As a matter of fact, on this view, so I'm going to hover over it and I'm going to right click on this view, edit view. I want to change what I see. Oh, it's not, I have to do it on the front view. There's a lot of lines, the hidden lines. I want to turn the hidden lines off. There's just too many to look at. Click OK. Now, I've gotten rid of the hidden lines, and that cleans up the image considerably. And that should help us create the dimension it properly so it's a little more legible. Click on Annotate and Dimension. And the first thing we're going to do is we're going to come in and dimension from here to here to get our 0.12. 1.2, sorry. We want to dimension the total thickness here. Try not to grab the green dots. And I don't have to put one on the other side because it's obviously a symmetric part. Now, the last thing I need is this. And we did have to have a center point, didn't we? So I'm going to go from here to here. I'm going to slide this up. Now I know those two numbers are on top of each other, so I'm going to hit Escape, and then I'm going to grab the 1.2 and slide it up a little bit. There we go. So those are the dimensions I need for the small triangular shape. I'm going to now do the large triangular shape down here. So we're going to dimension from outside here. I'll go ahead and slide that out 2 notches. Let's go ahead and do the dimension halfway to show that the peak is exactly halfway in the middle. It's mid. We can also show that this in fact is 0.25, just like the one up top. And then we need to see a height of this apex. All right, and so those are the dimensions for the second triangular shape. We created it using a loft, which once you have those two shapes, the loft is not a problem. We also did a shell, and we cut out these windows. So those are my next two things. So I'm going to do the thickness of the shell here. A dimension here to here. I don't think that's right. I think, yeah, it was the shell. I thought the shell was 0.1. So maybe I clicked on something extra. Let's try it this way. Here and here. Yeah, there we go. So I'm going to type it over here, but I'm also going to add the word shell to it. So make sure you're on text. Add the word shell so that the person reading this will know how we created that effect. I don't like this line going through the middle here, so I'm going to move this up top. That opens up the middle and we don't have any lines crossing. All right, let's go into the windows now. So we need to dimension the thickness of the window cutout. Thought it was 0.1, not 0.07. So delete, if you get a 0.07, delete that. If it's not working, hit Escape, and that clears all of your tabs, all of your buttons, and then you should be able to click on the number and delete. Right click, delete. The reason it gave me a 0.7 is the actual thickness of the cutout is 0.1, but from this view, because this is a slanted surface, it looks like it's only 0.7, because if we zoom in, this is narrower. So from here to here is narrower than here to here. So if this is 0.1, that's 0.07. But it's only because we're looking at a 3D object that's pointing towards us from a two-dimensional surface. So that's an optical illusion, but it causes the sketch to have different dimensions than what we know to be reality. Okay. So I'm going to type in here offset, because that's the tool that we use to create that window cutout. So I used a shell tool and I used an offset tool. And now over here is where I'm going to actually put, I'm going to slide this over some. I'm going to use my chamfer note here and my thickness here. So I'm going to go to chamfer, zoom in as much as we can, click on the angle, and then click on the surface here. And then down here, we're going to dimension from here to that. Make sure you get the outside. And I know it wasn't 0.13. It needed one more decimal place. So I'm going to change my precision to 3 decimal places. So that's the depth, or the extrusion depth, extrusion thickness. So the last thing I'm going to need, so what I want to do now is I want to get a back view so I can dimension the pegs. So I need to go back to place views. I'm going to go back into base. I'm going to bring a new base in as opposed to trying to do a projection. Same Cowcatcher, but this time before I stamp it, I'm going to rotate it to here. That's what I need. And I'm going to label this once we get to it. I want to get rid of those hidden lines. So click on the red dotted box, right click, edit view, click the middle button, and OK. And that gets rid of the hidden lines. Just cleans it up some. And now we need to go back and annotate. I want to get a distance from here to here. I can do a distance from here to here. Or I can do a chain dimension, but I think this will work fine. I need to get a distance from here to here. And then I need heights. You know what? Let's do the heights on this side. Once again, I probably want to put all of these at 3 decimal place precision. So I'm going to go back and do that on this one as well. So I hit escape, then I can slide these numbers over a little bit. And then we need finally we need the height dimension from here. I can do the height from the base. That's what I should do. I'm going to do that to here. But once again, that precision needs to be 3 decimal places instead of 2. So those are the locations of all of the pegs we now need. And this was the one we had trouble finding. We need a diameter. So I'm going to make sure I click the outside circle, not the inside circle, and pull a diameter, changing the precision to 3 decimal places. I know that looks a little cluttered. Yeah, well, it does. So let's see if we can. There's a lot of room here, so I'm going to slide this over just a little bit, trying to make sure I don't cut this off. As a matter of fact, I'm gonna redo this. I'm gonna hit escape and I'm gonna delete this. Slide this back over. And now I'm going to put my offset here on this side. That's just going to give me a little more room. Now what if I take this and I slide this up a little bit? Maybe here, maybe I do that. And now I can slide this over and open that space. All I'm trying to do is open the space up so that this is not so cluttered. Let's make sure we've got everything. We have the dimensions that we did for the small triangle, the dimensions that we did for the large triangle. We need extrusion. We don't have the extrusion thickness. So when we extruded from the small triangle to the big one, we had to create that offset plane. So we need a total height of this part. That's one thing we're missing. So here, I'm just going to dimension on the front view the total height. Small triangle, large triangle, the loft height between the two, the shell, the 3 pegs, the chamfer on the pegs, diameter, and locations. That's it. So now we want to save the drawing sheet as Cowcatcher, and we also need to go to File, and Export PDF.